Let's look at determining if a relation is a function. So first, a relation is just basically a relationship between two sets. You've got two sets of objects, and if the object X is from the first set and object Y is from the second set, then they're related if you can make the ordered pair X, Y in the relation, okay? The next part about this is there are certain types of relations that are called functions. And a function is a special relationship where each input has a single output. So basically, you're not going to look at or not going to see X values that are going to be duplicated. Lastly, your domain, which we're going to talk more about here in a future video, is the set of all X values. So that's usually the first values. And the range is the set of all Y values. Those are second values, okay? So the first thing that we need to do with these three examples is determine if this is a function. And then if it is, we're going to find the domain and range, okay? So one way to look at this is that these two circles are all the same problem. And this first circle you can think of as X's, and the second circle you can think of as Y's. And the arrows in between are basically showing the relationship between the two. So this 3 is matched up with -5. And so the whole point here that we're looking at is it's a function, okay? So it's a relation, but it's also a function if the X values are not duplicated. So you're going to just use one X value, okay? So is 3 only showing up one time? Yes, because 3 is matched with -5. Let's look at 7. 7 is matched with 9. It is not matched with anything else. So you're not looking at 7 matched also with 3. So 7, this part is good as well. 2 is matched with 3, that's unique, and then 1 is matched with 9. Notice that 9 is matched up to 2 different ones. That's okay. The Y's can be duplicated, but the X's cannot. So again, if I said the 1 is matched with 9 and the 1 is matched with 3, that would not be a function. But in this case, I don't have any X's that are used twice, and so this one is a function. So then if it's a function, what is the domain? The domain is going to be a set in set notation of all of the X values. That's the first values here. So we're going to just list this as 3, 7, 2, and 1. And we're going to close out that set with the little curly brace. The other thing is, if you don't like that not being in order, because a set, it has different elements and none of those elements have to be in a certain order. If you have to or feel the need to write this in order as 1, 2, 3, and then 7, go, feel free. Okay, you can. The order does not matter in a set. All right, range. Range here is going to be the Y value. So curly brace, 3, -5, and 9. Now 7 is matched to 9 and 1 is matched to 9, but just because 9 is showing up twice, I only have to write it one time in the range, okay? So you don't have to write duplicates. Let's look at our next example here. So our next example, again, this is our Y's, that's our X's, this is our Y's, and let's look at our relationships between these. So here the 4 is matched with 7, but the 4 is also matched with 9, and so when you see this, that means that 4 is duplicated, it is used twice, and that means it is not a function. So is this relation a function? We're going to say no. So we're not even going to find the domain and range there. Okay, and then our last problem here, we have a set of ordered pairs. Okay, so it can be expressed this way as well. What we're looking for is just the X values. Are the X values duplicated? So we don't care about the Y's, we're just looking at the X's. 5, -1, 2, and 1. None of those numbers are repeated, so this is indeed a function. But from there, since this is a function, we're going to do the domain. So the domain is 5, -1, 2, and 1. And then our range are the Y values. So 3, 3, 4, and -1. But remember, I don't have to write duplicates. So this would just be 3, just one time, and then 4 and -1. Okay? So that's a general idea of how to determine if something is a function, and then the domain and range from that from a set of ordered pairs. Okay, that's what you basically were seeing with these three. Now, before we go on, I want to show you real quick an example of why this doesn't work on a graph. Okay, I want to show you graphically. So let's say, this is just an aside here, let's say we have the numbers 1, 2, and 1, 3, or the ordered pairs 1, 2, and 1, 3. You don't have to write this if you don't want to, just watch. If I have the point 1, 2, we're there. If I have the point 1, 3, it's right there. What do you notice about these 2 points now that the x values are the same? What do you notice? Do you see how they are lined up vertically? Okay, so if you've got 2 points that line up vertically, that means it's not a function because the x values are the same and they will line up. Okay, all right, so in a graph, knowing this is really helpful because then it allows us to think about what's called the vertical line test. So in the same way that I had 2 points line up vertically, we can test a graph by using vertical lines to see if it is a function. So the vertical line test basically says if you can draw a vertical line anywhere on a graph so that it hits the graph in more than one spot, then the graph is not a function. So basically you're going to just draw a bunch of vertical lines and you're testing to see does it hit more than once anywhere. If it does hit more than once, it's not a function. If it only hits one time every single place you draw that vertical line, it is a function. Okay? All right, let's give this a shot. So looking at our first example here, we are determining if they are functions. So let's just draw some vertical lines here. How many times does that graph hit that vertical line? What about that one? What about that one? What about that one? And so this is the graph we're looking at. You can see that it hits 2 times there, 2 times there, 2 times there. So this is clearly not a function and does not pass the vertical line test. Let's look at our next one. We've got just 1 time there, just 1 time there, 1 time there, 1 time there, 1 time, 1 time. So really pretty much anywhere that I draw a vertical line, it's only hitting the graph 1 time. So this one is a function. And I think this last one's probably pretty easy to see that if I draw a vertical line, this one is hitting it honestly infinitely many times as that graph goes on and on. Okay, so this one is not a function. Now I want to make a quick note. Sure, I could draw a vertical line right here and technically it would only hit it in that one spot. But that's not what this is asking. It's not asking, hey, do you have anywhere on the graph where it only hits it once? That's not what it's saying. It's really asking the reverse. Do you have anywhere on the graph that it hits it more than once? And if it hits it more than once anywhere, it's not a function. Okay? All right, so I hope that helped with understanding that vertical line test and whether something would be a function or not.